When y'all were taking this quiz, by the way, and this is also the continuation of the pre-quiz. This is problem number 2 or page number 2. And so this entire video will be on page number 2 of the pre-quiz. I was really surprised how fast your groups got through this. And actually, I was pretty impressed with that. One of the common things I saw that was an issue on this is we did not show where the numbers in the table came from. It's like, oh, we did the calculations and we didn't, and we wrote the numbers down. And I'm sure you did it correctly. Unfortunately, if you don't show where the numbers come from, you don't get credit for it. And so you've got to show where those numbers come from, how you did it. So you're going to have to show these steps, even though you may feel like that's ridiculous. That's one of the things you've got to do is show where those steps come from. So a grocery store purchases melons from only 2 distributions, J and K. Distributor J provides melons from organic farms. The distribution of diameters of melons from distributor J is approximately normal with a mean of 133. I know this is going to be important. And a standard deviation 0.5. A randomly selected melon from distributor J has a probability of 0.21 of having a diameter. So there's a probability of 0.21 of having a diameter greater than 138 millimeters. All right. So in other words, if you have a randomly selected melon, there's a 0.21 chance that it's greater than 138. Distributor K, so that actually has 2 variables because that has where it's from and the size. So this is a 2 variable. Distributor K provides melons from non-organic farms. The probability is 0.84 that a melon is selected at a random from distributor K will have a diameter greater than 0.38. So once again, this is 2 variables. We have size and we have a and it has to be from distributor K. For all the melons at the grocery store, 70% of the melons are from distributor J. Hey, that's 1 variable. That's tied to where they're from, and it's only from distributor J. So that is my starting point. So I'm going to try to make this table where as nice and neatly as I can, but that's usually a stretch for me, especially while I'm talking. So we have J and we have K. And we have greater than 138, and I would probably write on a test greater than 138. Here I was going to symbol less than 138. And we know that if they came from distributor J, there's a 70% chance that they're greater than 138. And we also know that means distributor K is providing 30%. And this is 1 whole. And we need to write the 0.70 very small here. Now, a lot of you all did not do that. And if you didn't do that, you did not receive credit for showing your work, because I have to know where that comes from. So then I need to go back and look at my problem. A randomly selected melon from distributor J has a probability of 0.21 of having a melon greater than 138. Oh, that means that this right here is going to be 0.21. And I have to show that. And I need to have 1 minus 0.21 written here. Now, if you went just subtracted it directly and went 1 minus 0.21 and wrote 0.79, that is fine. But I have to have 2 numbers here and 2 numbers there so that I know where they came from. And these 2 have to sum to 1 whole. Then we have the probabilities point K that it is 0.84. That a melon selected from distributor K, so this column, is greater than, so again, once again, this time it went right here, 0.84. And 1 minus 0.84 is going right here. I have to have all that information, right? AP is going to require all that information or they're not going to give you credit for your work. So 0.7 times 0.21, and I end up with 0.147. When I multiply this times this, I end up getting 0.553. When I multiply this times this, I end up getting 0.252. And when I multiply this times this, I get 0.048. Summing these two should sum up to this, and they do. These two should sum up to this, and they do. Then I can sum my row across, and I end up getting 0.399. And then I sum this up, and I get 0.601. Okay. So for melon selected, so that's my table. And from there, I should be able to start answering questions. For a melon selected at random from the grocery store, what is the probability that the melon will have a diameter greater than 138? So I need to be making some sort of level, some sort of work shown, or some sort of label. So probability of greater than 138 equals, well, that's just the total of this row, which happens to be 0.399. And this is what I'd be looking for. If you just gave me that number because you showed your work in the table, I'd probably give it to you, and probably did. Actually, I know I did. But you need to have some sort of label saying what it is that you're finding. The next one, given that a melon selected at random from the grocery store has a diameter less than 138, what's the problem? Now, here we have a given. This was something that people did not do. They did not show their work on this. Given a melon selected has less than 138. So this tells me I have an intersection over given. Well, what were we given? We were given less than 138. So this means this is going to be 0.601 in the denominator. And it says what's the probability will be from distributor J. So basically, we are looking at this row and intersected with this column. So my numerator is going to be 0.553 because that's where this row and column intersected. And please do not leave this just like that. They will probably give you full credit for it, but really I would much prefer you go ahead and take it out to 4 decimal places, which is 0.9201. And I generally like to go 4 decimal places and truncate. I don't even worry about rounding. So please make sure that you're going 4 decimal places and rounding, and truncating. And this right here is adequate work shown that everyone's going to be very happy with that. The next thing, what's the probability? This is number 7. What's the probability that a randomly selected melon has a diameter less than 138 and was from distributor K? So let's read that very carefully. Diameter less than 138 and was from distributor K. They said nothing about from a specific group. So they're taking it from the entire population. So we're looking for the probability of less than 138 intersect K. And really, you've already done all of the work. All right. At that point, you've done all the work. So you're looking for intersecting of these two, less than 138, and from K, that's 0.048. So while I would have liked to have seen a label associated that looked something like this, if all I had was this, that's a full credit response because you showed your work up in the table. But notice, if I didn't have this information, I don't know where 0.048 came from. So you have to show where that multiplication came from, or you receive no credit. All right. Finally, number 8, what is given that a randomly selected melon comes from distributor K? So once again, we have a given, and we're given that it came from K. What's the probability greater than 138? So given K, so in other words, we're having to look at the K table, or the group of K. So K is going to be my denominator. So 0.30 is in my denominator. All right. And the next thing is, what's the probability that it's greater? What's the probability that it's greater than 138? Well, the intersection of K and 138 is 0.252. And that equals We'll take the calculator out and we'll divide that out. 0.252 divided by 0.30, and we end up getting 0.84. I need to see all of that. That must be shown. I really recommend writing intersection over given. It just helps people with their work. But 0.84 is not on that table. So you would have to show how it came from it. And you're like, well, it was kind of given to us in the problem. Doesn't matter. You need to show where it came from. All right. So moving on. What is the mean difference of the melon K minus J? So they want the mean of K minus J. Well, what do we know? So J has 133 and excuse me, 3, 5, and K has a need to pause for just a moment. I'm not seeing my. Okay, well, that's embarrassing. It was supposed to say, and so basically we're going to have to give you credit for 9 and 10 because it's missing information in the problem that you needed to solve it. So we'll have to give you credit for it. But it should have said that K or that J had a mean, or their mean of J was 133, and the mean of K was supposed to equal 130, was supposed to equal 144. It doesn't. So that's my fault. So we'll give you credit for these two, which would be basically 10 free points. So in this case, 144 minus 133 would equal 11, because I can do that directly. So I should have told you this up in the problems stem, but it didn't. So you can, because you can subtract means directly. The next thing it says it asks for the standard deviation. Well, it should have told you that the standard deviation of J, and it does, it tells you the standard deviation of J of 5, and it's supposed to tell you the standard deviation of K was equal to 7. But for some reason, I left that off, and that's my bad. So so we'll give you credit for these. So these are going to be, that's going to be free 5 points here and 5 points there. That's going to be free. But what this next thing that should, so what this was asking for is for you to subtract standard deviations. It was trying to lead you to go, okay, we want the standard deviation of K minus J. And then what we're trying to trick you into doing is going, all right, that's 7 minus 5. Well, you should have told me that, oh, no, can't subtract them, have to add them and square them and take the square root of them. All right, so that's what it was looking for. That information's not there, but you are going to be responsible for being able to do that, I believe, on this next quiz and definitely on the test. All right, so you're going to need to know that you can subtract centers, but you can only square and add measures of spread. My apologies for that information being missing. Oh, so once again, there's the table neatly written. Table neatly written along with 5 and 6. Might want to pause the video so you get that down. All right, and I'm going to scroll up. There's 7 and 8. And again, if you had just this part, that's good. So on this, we needed to have at least this. We needed to have at least this to receive credit on those two problems. And then problem 9 and 10, once again, we should have given you the mean of K, and this was the mean of K, and this is the mean of J, standard deviation of K, standard deviation of J, but I left that information off. That was my error. So we'll get you those points. All right, hopefully that helped. And please do know that you're going to be expected to do that on the test and maybe on this next quiz.